Okay, we are going to be talking about logarithms today, and this is something brand new. What we're doing is not going to be too difficult, but it is going to be brand new, so you guys need to make sure that you take really good notes, write down exactly what I'm writing down up here. If you guys do have any questions, write them down so that we can talk about them when we get back. So, starting out, before we talk about logarithms, we're going to talk about our exponential functions. Okay, so exponential function, y equals 3 to the x power. If I'm going to graph this parent function, that's where I'm looking at -1, 0, and 1. 0 always goes with 1, 1 goes with my base, and then -1 goes with the reciprocal of my base. So this function is going to be 0, 1, 1, 3, and then -1, 1/3. And then we don't want to forget our horizontal asymptote. So that's what our exponential function ends up looking like. And the reason that this exponential function is important is going to go back to lesson 50 when we talked about inverse functions. And one of the things that we talked about in our inverse functions was the horizontal line test. So our horizontal line test. And that horizontal line test would allow us to see if functions had inverses. So when I looked at my cubic function, your cubic function is a function that looks like this. Okay, if I ran my horizontal lines across, they only hit at one point. And what that told us is that told us that the cubic had an inverse, which the inverse of a cubic function is the cubed root function that looked like that. So what we're going to do today is we're going to use our horizontal line test here on our exponential function. So if I draw horizontal lines across this, all of these horizontal lines are only going to hit at one point. Okay, now it looks like down low here that it would hit at more than one point, but remember this part of the line is getting smaller and getting closer to that asymptote. Okay, it's just hard to show that. If we zoomed in, you could tell that it was getting lower, and you could tell that it only hits at one point. So what we find out is that our exponential functions pass our horizontal line test. And that means they have an inverse. So our exponential functions do have inverses because they pass the horizontal line test. So what are their inverses then? Well, a guy by the name of Napier decided that their inverses of exponential functions were going to be called logarithms. So by definition, a logarithm is the inverse of an exponential function. Okay? So if we're looking at our function here, y equals 3 to the x power, its inverse, the inverse of this function is going to be y equals log. Okay? So that's the log stands for logarithm. And this is said log base 3. So that 3, if you guys notice that 3 is a subscript, it's down below. So we're going to have log base 3 of x. Okay? So these two functions here are inverses of each other. And how do I know that they are inverses? Because their bases match. And their base here is a base 3. That's log base 3 of x. The base of our exponential function is 3. So the first thing that I want you guys to do today is I want you guys to be able to tell your inverses of each other. What are their inverses? And how do you know that they're inverses? Their bases have to match. The bases have to match. Okay? So, first example up here, I have y equals 5 to the x power. This is an exponential function. So the inverse is going to be a log function because the inverse of an exponential function is a log. So I'm going to have y equals log. Now in order for them to be inverses, their bases have to match. So this is a base 5. So that means I need a log base 5 of x. Their bases have to match. Okay? On the flip side, I've got a log base 2 of x. So this is a log function, and that means that the inverse of a log function is going to be an exponential function. Okay? So I've got a log up here. My inverse of that has to be an exponential function. So that's going to be y equals, now I need to know what my base is. Well, this is a log base 2, which means that I'm going to have a 2 to the x power. These are inverses. These are inverses. Okay? Pause the video real quick and try and do these bottom two. See if you can figure out what the inverses for these bottom two are. So pause the video. Okay. So for this one, I have an exponential function. So my inverse is going to be a log. And my exponential function has a base of 4. So my log needs to have a base of 4. So this is going to be y equals log base 4 of x. Okay. Now this one over here on the right, that's a logarithm function. So its inverse needs to be an exponential function. So I'm going to have y equals something to the x power. Well, I'm going to check the base. This is a base 6. So this is going to be y equals 6 to the x power. Okay. So again, the most important part of this, the inverses. Exponentials and logarithms are inverses of each other. Okay. So since they are inverses of each other, or the only way that they are inverses of each other is if their bases match. Their bases have to match. So like let's say I was looking at this. Let's say I had a log base 2 of x and a 3 to the x power. Are those inverses? Bases do not match. So they are not inverses. Okay? These two down here, though, bases do match on these two. This and this, they match. They are inverses. Bases match here. They're inverses. Bases match here. They're inverses. Bases match here. They're inverses. Bases do not match up here. They're not inverses. Okay? Now, inverses are helpful because inverses allow us to cancel things. Okay? So my first example that I have over here on the left, I've got a log base 3 of 3 squared. And this is really kind of in 3 parts. 2 parts. Wow, I'm sorry. This is kind of in 2 parts. Okay? What I have up here is I have a log base 3 of something. Okay? I have a log base 3 of something. And then I have a 3 to some power. Okay? So if I'm looking at my log base 3 of x, and I'm looking at my 3 to the x power, those two are inverses of each other, correct? They have the same base. One's a log, one's an exponential function. Now what that means is, since those two functions are inverses of each other, I can cancel. So if I ever see something like a log base 3 of 3 squared, I can cancel my log base 3, and I can cancel my 3 here, my base 3 on my exponential function. So this answer, okay, after I cancel my log base 3 and I cancel my base of 3 on my exponential function, all that I'm left with is a 2. So a log base 3 of 3 squared gives me just a 2. Now, this isn't a squared, okay? Sometimes people will want to write their answer like this and be like, oh, it's a squared, it's small. It's not a squared, it's just the number 2, okay? This is new. You've never seen something like this before, okay? The reason that we can cancel, I have a log base 3 and a base of 3 in this exponential function. Their bases match, so they are inverses. You can cancel them. Okay, that's something new. Next, over here on the right side, okay, now this one is a little different. Okay, I've got a 4 to some power, 4 to some power, and then I've got a log base 4 of something. Again, I've got a log and an exponential function, and they have the same base. That means that they are inverses of each other. Okay, so this is just the opposite. I've got a 4, and then there's a log base 4 of 5. That's up in the exponent. That's in the exponent there. Okay, So maybe we can write it like this. That's a 4 log base 4 of 5. Okay, that's what that is. If you can't tell, that log base 4 of 5 is up in the exponent. So, since those are inverses of each other, I've got a base of 4, I've got a base of 4, I can cancel those. And my answer is going to be what's left over. So in this case, my answer is a 5. Okay, not an exponent 5, it's just the big number 5 there. Okay, so these are two new things that we can do, and the reason we can do that is because their bases match. Okay, now if I look at this example down below, down here, this is a base of 3, and this is a 9 to the first power, that's a base of 9. Do their bases match? No. One of them's a 3, one of them's a 9. Okay? So I cannot, right now, I cannot cancel anything. However, I can rewrite this. Okay? I've got a log base 3, but there's another way to write 9, right? We could also write 9 as 3 squared. You guys agree, right, that 9 and 3 squared would equal the same thing? So all I'm doing is instead of writing a 9 here, I'm writing a 3 squared. And why is that helpful? Well, now, base of 3, their bases match. And we are left with just a 2 for our answer. Okay? Let's do a couple other practice ones. Okay, you guys can do these off in the margins. Let's mark this one out for now. Okay. One of them that I want us to do, let's do a log base 3, no, let's go log base 2 of 8. Okay. Let's go log base 4 of 16. And let's go log base 5 of 25. Okay. Let's answer those real quick. Okay, so our first step, log base 2 of 8. I've got to rewrite this so that it has a base of 2. So how can I rewrite 8 so that it has a base of 2? Well, 2 cubed, it's a 3 there, 2 cubed, that's a really bad 3 there. Okay, that's better. So 8 is the same thing as 2 cubed. So I could rewrite that 8 there, and I could rewrite that 8 as a 2 cubed. Now their bases match, and I get that my answer for this is 3. Okay? Next one. We'll come back and do that one. Next one, I've got a log base 4 of 16. I need to rewrite 16 so that it has a base of 4. Okay? Well, 16 equals 4 to what power? What does that power need to be? Well, that could be 4 squared. Okay? So I can rewrite this as a 4 squared. Now their bases match, and we get 2 for an answer. Okay? So this part right here is essentially what you're asking yourself. You're rewriting it. You rewrite it so that the bases will match. Okay? And then once your bases match, that's when we are able to cancel. Okay? All right. Try these on your own here real quick. We'll see what we can get out of this. Okay. So this one here, log base 5 of 25. I've got to make this a log base 5 of 5 to some power. So what's the relationship between 25 and 5 to some power? Well, 5 squared would equal 25. So I can cancel those, and my answer is 2. Okay, next one. I have a log base 3 of 1 over 9. Okay, now this looks a little bit different. However, our strategy for this is still the exact same. I've got a log base 3 of 1/9. I need to make this a log base 3 of 3 to some power. Okay? So the rule doesn't change. These two bases still have to match. So how do I get from 1/9 to 3 to some power.